Hi. In our last video, we looked at how we find future value of a single lump sum payment, dealing exclusively with annual compounding. Now we're going to see what happens if the compounding is more frequent than annual. So let's use a common example that a lot of you, I'm sure, are very familiar with, and that is with a credit card. Now, not all credit cards work exactly this way. So if yours doesn't work exactly this way, that don't get concerned. But this is just to use this as an example. So let me bring up the whiteboard here. And so many credit cards will have monthly compounding. Okay, not all of them, but many of them will. So let's suppose we have a credit card with monthly compounding, and let's suppose the monthly interest rate is 1.5%. So the interest rate is 1.5%. That's a monthly rate. So each month we're charged 1.5% in interest. And of course, as a decimal, that's 0.015, right? 1.5% is 0.015. Now, let's suppose that you go to a store and you want to buy a pair of shoes, okay? And suppose the shoes cost $100. So you got $100 there to buy a pair of shoes, and you buy them and you put the cost on your credit card. And your credit card, of course, has an interest rate of 1.5% per month. And you wait 2 years before you pay off the credit card. Now, I know you have minimum scheduled payments and everything. Let's just ignore that. So you don't make any payments for 2 years. How much do you owe at the end of these 2 years? That's going to be the future value. How do you find this? The same way we did before. We're going to say that future value is equal to the present value times 1 plus r to the t, where the present value is, in this case, the $100 that you are charging, the cost of the shoes, what you're charging and putting on the credit card. So that's going to be equal to 100. Now remember, r is our interest rate per compounding period. We have monthly compounding, which means that at the end of each month, the credit card company is going to add some interest on to our charge. So that's going to be 1.015, right? That's 1 plus 1.5%. raised to the t. Now, t has got to be the number of months. It's the number of compounding periods, right? So we cannot have a monthly interest rate with the number of years up here. That won't work, okay? So if this is a monthly rate, we've got to have the number of months. Of course, in 2 years, there is 24 months. So this is the math problem that we need to solve. What is 100 times 1.015 to the 24th power? That'll tell us how much money we owe on our credit card at the end of 2 years. But of course, I don't expect you to get out a pen and pencil and try to figure out what's 100 times 1.015 to the 24th power. That's what Excel is for. But you have to know what is it that Excel is solving, okay? That is the math problem Excel is solving there. So let's go back to Excel, okay? And bring it up here, and we're going to say equals FV for future value, plug in our bracket, go to the function wizard, and the rate is our interest rate per compounding period. So that's going to be 1.5% per month because we have monthly compounding. So that's 0.015, okay, that's 1.5%. Then the number of periods is going to be how many compounding periods. If we have monthly compounding, there's going to be 24 months in 2 years. So if I want to, by the way, I can do 2 times 12, and Excel will give me, we'll work that out because Excel knows 2 times 12 is 24. But we'll just plug in the 24 there. And so the present value is how much we are charging at time 0. If I put in a positive, my answer will be a negative. If I put in a negative, my answer will be a positive. I don't care which you do, okay? As long as you know that at the end of the 2 years, you owe a certain amount of money. It's not that the credit card company owes you the money, okay? So we'll just put it as a positive, $100. Okay. So I put $100 in there. So this is what Excel needs to solve that problem, to say what is 100 times 1.015 to the 24th power. And that you put this information there and Excel will solve that for you. And it says, except that Excel will turn around the sign and give us the answer as a negative number. So Excel says, hey, you're going to have to owe $142.95. So clearly $100 is what you charged, but you've racked up $42.95 in interest over these 2 years, because it's compounding not at the end of every year, it's compounding at the end of every month. So let's go back over to our whiteboard and see how this is happening here. So at the end of the first month, what do you owe? You owe 100, okay, times 1.015. And what do you owe at the end of the second month? Okay, you owe 100 times 1.015 to the second power, and so forth. And out here is time 24, which just means you're going to owe 100 times 1.015 to the 24th power. And what is that you're going to owe? You're going to owe $142.95. So the first rule there is you pay off your credit card during the first month, and you only have to pay $100 for those shoes. You don't have to pay $142.95 for the shoes. Okay, but this is not a personal finance course, but that's a good thing to remember anyway. So that's what you owe at the end of the 2 years. You owe $142.95 on the credit card. Now, when you hear interest rates being advertised, okay, they typically won't tell you what is the monthly rate. And it's not that they're trying to be deceptive or anything like that. There are truth in lending laws. And these laws say that financial institutions must quote you an annual rate, because even though there's monthly compounding, we all just think annually. Now, there's two ways to get an annual rate. There is the one that institutions are required to quote, okay? And unfortunately, that gives you the wrong answer, as we're going to see in a minute. But then there's another way that you can quote an annual rate that gives you the right answer. And we're going to learn both of these. The one that is most common, that all institutions are required to quote, is called the APR, the annual percentage rate. In fact, you can just automatically assume whenever you hear an interest rate, it is an APR. It's an annual percentage rate. 99% of the time when you hear an interest rate, that's what it is. It's an APR. The interest rate that they quote you on your credit card, it's an APR. If you're quoted an interest rate for a mortgage, it's an APR. You're paying monthly on your mortgage, but it's an APR. How about for a car loan? It's an APR. How about if you hear what is the yield on a 3-month treasury bill? It may only be a 3-month treasury bill, but it's an APR, basically, is what is being quoted to you. So always assume, unless you hear otherwise, that an interest rate is an APR. So how do we get this APR? Well, if we have monthly compounding, the true interest rate is a monthly rate. If you have monthly compounding, the interest is a monthly rate. In other words, you have your first amount of interest is tacked on at the end of the first month, not at the end of the first year, at the end of the first month. So you get 1.5%. Okay, interest is tacked on to how much you charged at the end of the first month. There's no additional interest until the end of the second month. Then there's another 1.5% added on there. Okay, 1.5% of what you had at the end of the first month. And then at the end of the third month, you get 1.5%. So at the end of monthly compounding means at the end of each month is when the interest is tacked on there. And it compounds, okay? It's always interest on the principal and on all of the interest you have accumulated up until that point in time. So the way we find the APR is really very simple, and this is why it's so common. We just simply take our monthly interest rate. If I've got monthly compounding, we're going to take the monthly rate, okay, here. And we're going to simply multiply it by 12 because there are 12 months in a year. And that's going to give us the APR, okay, the monthly rate times 12. So in our example, the monthly rate was 1.5%. So what is 1.5% times 12? 1.5% times 12 is going to be equal to 18%. So the APR is 18%. So if the credit card company tells you the interest rate on this loan is 18%, you can just automatically assume it's the APR they're talking about, okay? But then if they say we have monthly compounding, you got to say, aha, the real interest rate is a monthly rate if we have monthly compounding. So how do you get that monthly rate? Well, it's really easy. You just take the 18%, 0.18, and you divide it by 12, and that's going to give you 0.015, which is equal to 1.5%. So the monthly rate is 1.5%. So if you're quoted an APR, then you have to say how frequently is the money being compounded. In this example, it's being compounded monthly. So you divide that by 12, gives you the monthly rate, and that's the true rate that you need. Now, as I mentioned before, the problem with the APR is it gives you the wrong answer. Okay, let me show you what I mean by this. Let's go back to Excel here. And let's take this and we're going to copy it down here. And what we're going to do is we're going to make just a couple little changes to this, okay? We're going to go back to our function wizard. We're going to say, instead of the rate being 1.5%, let's make it 18%, which is the APR. And let's make it 2 years. So we want to see, is 18% for 2 years the same thing as 1.5% for 24 months? And the answer is no, it's not. 18% for 2 years understates how much you owe. What you owe is really $142.95 because you had monthly compounding. But what it means is that 18% for 2 years is not the same thing mathematically as 1.5% per month for 24 months. And what you have here, if you have monthly compounding, you do have 1.5% for 24 months. But this is the way it's quoted to you. You'll see it on the envelope when they send you the credit card agreement, okay? It's going to say 18% APR, and then in small print down at the bottom, it's going to say monthly compounding, right? So you need to know that 18% for 2 years understates the true rate. You actually owe a little bit more than the $139.24. You're going to owe $142.95. So what's the other way that we can get monthly compounding translated or transcribed or converted to an annual number, one that will give us what we really do owe, the $142.95. So what happens here is there must be some rate we can plug in. Let's go back down here. There must be some rate we can plug in other than 18%. It's got to be something higher than 18% that after 2 years will give us the correct amount that we owe, $142.95. That's called the EAR. Now, you probably thought the EAR was that thing sitting on the side of your head. Well, it's actually in finance the effective annual rate. EAR is the effective annual rate, and it is the rate that gives you the same answer, okay, $142.95 with annual compounding as we got with monthly compounding. So let's go back to our whiteboard and let's see how we go about doing this. How do we find the EAR? Okay, well, we already saw that we have 1.5% per month. Let's go to the next page here. To find, if I've got monthly compounding, the way you find the EAR, and we're going to, some people, the way I like to express it is like this. I like to say 1 plus the monthly rate, and this is if we have monthly compounding, 1 plus the monthly rate is equal to 1 plus the EAR raised to the 12th power. And of course, that's 12th power because there are 12 months in a year. 1 plus the monthly rate is equal to 1 plus the EAR raised to the 12th power. Now, if I just want to find the EAR by itself, okay, what do I want to do? I can say that, man, sorry, I made a mistake. Please forgive me. You probably realized it before I do. This is wrong here. It's not 1 plus the EAR raised to the 12th power. 1 plus the monthly rate raised to the 12th power equals 1 plus the EAR. Sorry about that. So at any rate, what we need to do, if I want to find the EAR by itself, okay, what I have to do is I subtract 1 from each side. So I can say the EAR is equal to 1 plus the monthly rate raised to the 12th power minus 1. Okay, so that's pretty easy. Now, what happens if my money isn't being compounded monthly? Suppose it's being compounded weekly. In other words, at the end of every week is when I earn my interest, if I'm receiving interest, or when I have the interest credited in my account if I'm having to pay out the interest. Then you would say 1 plus the weekly rate, if I've got weekly compounding, 1 plus the weekly rate raised to the 52nd power, because there are 52 weeks in a year, equals 1 plus the EAR. Okay, and if I just want to get the EAR by itself, I say the EAR, if I have weekly compounding, is equal to 1 plus the weekly rate raised to the 52nd power minus 1. What if I have daily compounding? If you have daily compounding, and there's a lot of things that do compound on a daily basis, a lot of loans that do that, you would then say the EAR is equal to 1 plus the daily rate raised to the, how many days are in a year? 365th power minus 1. So you can see what's happening here is that if you want to find the effective annual rate, okay, you first ask how frequently is the money being compounded. Okay, if it's being compounded monthly, then you say 1 plus the monthly rate raised to the 12th power minus 1. That gives you the effective annual rate. If it's being compounded, for example, daily, then you say 1 plus the daily rate raised to the 365th power minus 1 gives you the EAR. Well, let's go back to our example, okay, with the credit card, where we had 1.5% per month. Where we had 1.5% per month, we're going to say 1 plus 1.5%, 1.015 raised to the 12th power minus 1. That's going to give us our effective annual rate. And that effective annual rate is going to end up being 19.562%. So that's going to be equal to 19.562%. There's more decimals than that, but that's rounding it pretty well there. 19.562%. That means if I have monthly compounding, okay, where it's 1.5% per month, effectively, that's the same thing as getting 19.562% per year. And we can see this if we go back over to Excel, and we're going to go back over here. Now notice when we had 19%, it wasn't the same. Here is my 1.5% per month for 24 months. Okay, I owe $142.95. And that is what I owe because it is monthly compounding. But effectively, okay, that's the same as we said 19.562% per year for 2 years, because that also says that I owe $142.95. So the APR, which is what everybody uses, understates how much you owe at the end of the 2 years. The effective annual rate will tell you correctly how much you owe at the end of the 2 years. Now, the EAR, if you've ever heard the term effective annual yield, okay, um, uh, uh, that's the same thing, or APY, annual percentage yield. That's the same thing. The APY is the same thing as the EAR. If you've heard those terms, your textbook uses APR and it uses EAR. So that's what we're using here in this particular example. So let's go to our class notes so that I can take a look at what we've got, show you something that we've got there. So I'm going to bring them up. And we're going to see here in the class notes, and this is kind of, I think, at the bottom of page 4 of your class notes, that when you have annual compounding here, okay, the EAR and the APR are the same. APR and EAR are the same thing when you have annual compounding. So 1 plus the EAR is the same thing as 1 plus the APR. Now, if you have semi-annual compounding, okay, then you want the semi-annual rate. Well, the semi-annual rate, if you have semi-annual compounding, is the APR over 2, right? So 1 plus the EAR is 1 plus the semi-annual rate raised to the second power. And the semi-annual rate is the APR divided by 2. If you have quarterly compounding, then the quarterly rate is the APR divided by 4. That's the quarterly rate. So 1 plus the quarterly rate raised to the 4th power is equal to 1 plus the EAR. And you can see what happens with monthly, if you got daily, weekly, and then daily, okay, as we mentioned, is going to be 1 plus the daily rate. The daily rate, if you have daily compounding, is the APR over 365. Raise that to the 365th power there, and that's going to give you 1 plus the effective annual rate. Now, notice what's happening here. As we get the compounding more and more frequently, right? Like we had annual compounding, then semi-annual compounding, then quarterly, then monthly, then weekly, daily. As we get the compounding periods getting shorter and shorter, what's the shortest we can get is continuous compounding, okay? You get daily compounding. Can you have monthly compounding? Can you have hourly compounding? Yes. Can you have compounding every minute? Yes. Can you have it every second? Yes. Well, how close can you get that? Continuous compounding is where you have no gap between the compounding periods. It's always compounding, okay? And for this, we approach, if you've had calculus, this is the concept of the limit in calculus, okay? What do we get when we compress this time period to the limit, where it says the time period is as close as possible? And now we have a little bit of problem with our formula. The problem is, if this is the number of compounding periods in a year, okay, well, when you have continuous compounding, it's an infinite number of compounding periods in a year. So we have to come up with a different formula, and we have to use the letter E here. The letter E is used when we have continuous compounding. Now, the letter E in finance is not a letter, it's a number, okay? And we're going to talk more about this when we get into our next video, when we deal more specifically with continuous compounding here, okay? But we're not going to get into the continuous compounding as much right now. But let's scroll down just so we can see a little bit more here when we've got our compounding over different time periods. So let's suppose that you go to the bank and the banker tells you that the APR is 10%. And that's almost always when you hear an interest rate, it's an APR. So the banker tells you the APR is 10%. Well, that's great. That's informative, but that's not all the information you need. You also need to know how frequently is the money being compounded, right? So if you have annual compounding, that means you get 10% at the end of each year. And that is effectively 10%. When we have annual compounding, the APR and the EAR are the same thing. But if we have semi-annual compounding, when you're told the APR is 10%, the true interest rate is a semi-annual rate. So there are 2 semi-annual periods in a year, So that means your true interest rate is going to be 5% every 6 months, 0.05 every 6 months, 1 plus R raised to the T, okay, 2 semi-annual periods in a year. That's going to give you this number, and then you subtract the 1 from that, and that gives you an effective annual rate of 10.25%. So if the compounding is annual and the APR is 10%, you're getting 10% every year. But if it's semi-annual compounding, you're effectively getting 10.25%. Quarterly compounding, then it's effectively going to be 10.38%. Monthly compounding, it's effectively going to be 10.47%. So you can see as the compounding gets more and more frequent, as it's a shorter time period that you have to wait to get interest on your interest, effectively that is boosting the interest rate that you are earning, or boosting what you're paying if you're the one who's paying the interest rate. So when we get to daily compounding, it's a little bit more than 10.51%. And then with continuous compounding, it's just a little bit more than daily compounding. So I don't want you to think that continuous compounding means, man, your money's going to explode overnight. Nah, it's only just a little bit better than daily compounding, because time-wise, going from a day to continuous is like 1 day, okay? It's a bigger difference going from annual to semi-annual, because that's a 6-month difference there, okay? So that is going to be calculating the effective annual rate. So what you want to remember from this, okay, is that you not only need to know what is the interest rate, but you need to know how frequently is the money being compounded. And the true rate you want to know is going to be the interest rate per compounding period, so that you got to know what the compounding periods are. If you have monthly compounding, the true rate is the monthly rate. If you have weekly compounding, the true rate is the weekly rate. But what everybody's going to tell you is the APR. If it's weekly compounding, the APR is the weekly rate times 52. If you have semi-annual compounding, the APR is going to be the semi-annual rate times 2. If you have monthly compounding, the APR is going to be the monthly rate times 12. So we now know how to get from the APR to the true interest rate, and we also know how to express it as an effective annual rate, which will mathematically give us the right answer in terms of how much we owe at a particular point in time. All right. So in the next video, we're going to go down here to this concept, which is kind of a curious concept, and but a very interesting one, and one that's used a lot in finance, that concept of continuous compounding.